Good morning. Welcome to another session of EE403 Distributed Generation and Smart Grid. In this session, we will be seeing various energy storage devices. Before starting the next slide, let us see a quote by Dr. APJ Abdul Kalam. Dream is not what you see in sleep. Dream is something which doesn't let you sleep. So we are in module 2 right now. In the last class, we discussed about wind energy conversion systems, and today we will see various storage devices like batteries, ultracapacitors, flywheels, etc. The energy storage market is steeply increasing. You can see from the graph from 2018 to 2026, the market is expected to reach, you can see, 211,200 million US dollar. This is a news dated August 21, 2019. Advanced energy storage system market to reach 211.2 US billion by 2026. Increasing number of solar farms will provide impetus. So this is a very important news article. And a large number of storage technologies are available for various applications, and all these technologies depend on our power rating and also how much time the storage devices can hold the power. So you can see here, if you want high power rating from 100 megawatt to 1 gigawatt, ordinary batteries, supercapacitors, etc. cannot help. We have to go for pumped hydro electric systems or CAES. These things we will see later. So if your requirement is for few seconds or minutes, then if it is for few seconds, flywheels can help, high power supercapacitors can help. If your requirement is for few minutes, up to 10 megawatt, lithium-ion batteries and other types of batteries are available. So depending on your requirement, we have to go for one of these storage technologies. So energy storage system, especially electrical energy storage system, we can divide into basically 5 types: mechanical, electrochemical, electrical, chemical and thermal. In mechanical, we have pumped hydro PHS, compressed air CAES and flywheel FES. In electrochemical, we have secondary batteries, various types of batteries, flow batteries, and in chemical we have fuel cells, etc. In electrical we have double layer capacitors, or we call it supercapacitors, or superconducting magnetic coil SMES. And in thermal we have sensible heat storage. You can see here this base is a Tesla Model S car battery, and you can see its capacity of 100 kilowatt hour, and it can go for almost 735 kilometers. Of course, it depends on the road conditions. Storage technologies we can divide into batteries, flywheels, ultracapacitors, superconducting magnetic energy storage, pumped storage, hydroelectricity, compressed air energy storage, electrolysis of water and methanol, but we will be more interested in storing the electrical energy. So we will be looking into batteries, flywheels and ultracapacitors only, not the other storage technologies. The basic principle of a battery, all of you know already. There are two electrodes and electrolyte, and the battery can be charged and discharged. There are different types of batteries, lithium-ion batteries. The pictures are shown here. Now each lithium-ion cell has essentially three components: a positive electron, it can be lithium cobalt oxide or lithium iron phosphate, a negative electrode, normally carbon or graphite, and an electrolyte. When the battery is charging up, the lithium cobalt oxide positive electrode gives up some of its lithium ions, which move through the electrolyte to the negative electrode, which is normally graphite, and remain there. The battery takes in and stores energy during this process. When the battery is discharging, the lithium ions move back across the electrolyte to the positive electrode, producing the energy that powers the battery. In both cases, electrons flow in the opposite direction to the ions around the outer circuit. Electrons do not flow through the electrolyte. It's effectively an insulating barrier so far as electrons are concerned. Flywheels store energy in the form of kinetic energy in a rotating hub, but it is only for small durations. The pros and cons of flywheel. The pros are the low maintenance and long lifespan, almost no carbon emissions, very fast response time, and no toxic components. And the cons are high acquisition cost, low storage capacity, and self-discharge. Around 3 to 20% per hour gets discharged. Ultracapacitors or supercapacitors. The easiest way to increase capacitance or increase the energy storage is to increase the surface area A or decrease the plate separation of a capacitor. So this is what exactly a supercapacitor do. They are also known as electric double layer capacitor, electrochemical double layer capacitor, or simply double layer capacitor. You can see in the picture the number 1, this is a power source, and these are collectors, 2, and this is also a collector, and 3 is a polarized electrode on both sides, and 4 is Helmholtz double layer. This is Helmholtz double layer, and the 5th one is an electrolyte having positive and negative ions, and 6th is a separator. So this is the construction of an ultra capacitor. So you can see here the charging, the completed charging, and the discharging is shown in 3 different pictures. Red are positive ions and blue are negative ions. When charging, the positive ion move towards the cathode and the negative ions move towards the carbon electrode anode. And when the charging is complete, or we call it ion absorption, you can see all the positive and negative near the electrode, and when it is discharging, the opposite happens. So it is ion desorption. So you can see this forms an electrical double layer. If you compare a battery and a supercapacitor with sportsman, a sprinter can be compared with a supercapacitor, and a marathon racer can be compared to a battery. So It means a supercapacitor has more power required for small time interval, whereas a battery is equivalent to a marathon racer. He constant but less power required for large time. This is a comparison of a battery and a supercapacitor. The cycle of life of battery cells is restricted to 1000 discharge or recharge cycles, whereas the life of a supercapacitor is only 100 times shorter than the conventional electrochemical cell. So the life of a supercapacitor is less. The electron transfer occurs across two electrodes with the electrolyte as the medium transfer. Redox reaction across the double layers in the form of Helmholtz capacitance and space charge capacitances. In a battery, the charge storage by redox reaction occurs in the battery and it has low power density, whereas a supercapacitor has high power density, functions over a large range of temperature. This is another comparison of battery and lithium-ion battery and a supercapacitor. You can see the charging time of a lithium-ion battery is up to 1 hour, whereas a supercapacitor can charge in 10 seconds. The cycle life is 500 or higher, whereas supercapacitor is 1 million to 30,000 hours. Cell voltage is between 2.3 to 2.75, whereas for a battery is 3.6 to 3.7 volt. Then about the specific energy, this is important because that decides its weight per watt hour. So it is only 5, where it is 100 to 200. So supercapacitors are small in size. So service life 10 to 15 years. Here it is 5 to 10 years. So the supercapacitor life is more. And these are the temperatures. So moving to the next slide. Benefits and limitations of supercapacitors. A supercapacitor has virtually unlimited cycle life. It can be cycled millions of times. It has low resistance to high load currents. Excellent on low temperature charge and discharge performance. Cost effective energy storage. It can charge in seconds. It can easily disposed because it is made out of carbon. Low specific energy, holds a fraction of a regular battery. Linear discharge prevents using the full energy spectrum. High self discharge, higher than most of the batteries. Low voltage cell, high cost per watts. So those shown in black alphabets are pros and in red they are cons. This is a discharge curve comparison of a battery, a supercapacitor and a compressed air. You can see a battery, the discharge curve is exponential but provides a steady power almost till the end. Whereas here the discharge curve is linear, so it prevents the full use of energy. And in compressed air, it is an inverse curve, so the best performance is at the beginning only. So these are some of the references which you should go through. Thank you very much. This is Dr. Unnikrishnan PC signing off.